Hello, I'm Jionghao from the team Personalized Learning Square Plus at Carnegie Mellon University. Today, I would like to share our recent work, How Can I Improve Using GPT to Highlight the Desired and Undesired Parts of Open-Ended Responses. So our study mainly focuses on the tutor training. So we aim to provide automated feedback to further improve the tutor performance on answering some questions from our tutor training platform. We proposed two research questions in our study, and I also put the screenshot of our demo feedback system. So you can see the tutor, they can type a response in our system, like you are doing a great job, let's continue on the problem. And our feedback system can highlight the key components of the tutor response and then further provide the template-based feedback to help the tutors further improvement. And I also provide a link to our feedback system. We provide several predefined examples in our system, and you can also try your example by using your OpenAI API key. So here is a bit of background about tutoring. So as we know, tutoring is one of the most effective instructional methods which can help the students learning. However, we find that finding the qualified tutors actually is difficult. And training the tutors to be the qualified level is more difficult. The most difficult part is to provide tutoring for all the students. To address this issue, Personalized Learning Square Plus is kind of like a platform designed to optimize the tutoring process. And I also provide a link to visit our Plus to the training platform. So here is the main view of our Plus training dashboard. So that once the tutors log into our platform, they can select one of the lessons, such as supporting a growth mindset. And once they enroll the lesson, we provide a set of questions. So here is the investigated questions in our study. That is a scenario-based question. So you can see we provide some context or the question scenario. Let's imagine you are tutoring a student named Kevin. And when the Kevin answered the question correctly, what kinds of praise will you provide to encourage Kevin's on the further step? So we also answer these kinds of questions for the tutors to answer it. So the trainees tutors, they can put their response in the box, and we will use our feedback system to assess the quality of the tutor response. So that brings to our general research question. How can we use the AI, particularly generative AI, to provide feedback to the tutor trainees? So we put two research questions in our regional papers. In my today's presentation, I use the brief version. The first one is, does prompting GPT model provide accurate explanatory feedback for the tutor training? And then the second one is, does fine-tuning approach further improve the model accuracy? So the main focus of this study is the lesson like giving effective praise. And we aim to train the novice tutors to give the praise for the effective praise for the middle school students. And according to the tutoring practice and also some principles, the effective praise should be perceived as sincere and truthful and detail the student's learning process and should not be in the generic form, for example, like great job, well done. And in our study, we categorize the praise into two types. So the first one is effort-based praise, focus on the student learning process. The second one is less desired one, or undesired praise, that is outcome-based praise, focus on the student's achievements. Some examples like great job, well done. And our solution for the feedback provision is to highlight the key components of the praise in the tutor responses. So we use a blue for the effort-based praise, red for the outcome-based praise. Once the tutor put a response in our system can capture these key components from the response and then further provide the template-based feedback for the tutor's training. And also same for the outcome-based praise. For the undesired praise, we can further provide suggestions. For example, you should focus on praising the students for their effort and process towards learning to better help the trainee tutors understand the desired form of the praise. So to develop this feedback system, we first collected 129 training responses from our tutor training platform. And then we invited some experts to annotate and also to label the key components of the praise from the tutor responses. And then to answer the research question 1 and 2, we further prompt and also to fine-tune the GPT models like 3.5 and 4 models to further provide the explanatory feedback for the tutor training. So for the research question 1, here is the highlights results. So we proposed and validated a novel metric called modified intersection over union, or M-IoU score, to measure the quality of the highlighted components identified by the GPT models. And then we further investigated the performance of prompting GPT models to highlight the desired and undesired components from the training responses measured by M-IoU score. So here, let me give you a brief background about the quality. How did we measure the quality of the key components? So the first row, John, you are making a really great effort. Great effort is kind of like a notation from the experts. So we consider it as the ground truth, and we can give it a perfect score like 1. And from our model predictions, it sometimes can predict some extra words, for example, like really great effort, a really great effort, and making a really great effort. So you can see these extra predictions, they also capture the attributes of effort-based appraise. That's great effort, but just put some extra words in the final predictions. So we want to give smaller penalty for these kinds of extra predictions, as it can still show the meaning of the effort-based appraise. But regarding some mispredictions, for example, like here, grades, the model can only identify the grades from the response. It actually is a bit of unclear what kinds of praise it is, so we should put larger penalty for the missing predictions. Inspired by the traditional measures like F1 score and also the intersection over union score, we want to give like smaller penalty for the extra predictions and a larger penalty for the missing predictions. That's why we propose the modified intersection over union, or M-IoU scores here. So for this metric, we assigned alpha with the false positive, and we give the alpha value like 0.2 as based on our observation in the experimental process. So the M-IoU score is used to measure the quality of a highlighted component of the tutor praise responses. And we further invited 2 human coders to evaluate the quality of the highlighted responses from the expert annotation and also the GPT predictions using the 5-point Lecter scales. So here is the validation process for the M-IoU score on the effort-based appraise. So you can see the results show significant correlation between the human coders and the M-IoU score, which indicate that our M-IoU score can be considered as a surrogate or proxy of the human ratings. And also same for the outcome-based appraise. It also shows a significant correlation. And here's the results for our research question 1. We noted that the human coders rate experts' highlights as accurate about 80% of the time, and they rate GPT 3.5 as accurate about 65% of the time. It should be noted that in our study, we found that GPT 3.5 prompting GPT 3.5 outperforming the GPT-4 model. And then, as we know, the human coders, the score for the expert annotation is 0.77 and also 0.87. And then we want to further understand what are the values for the M-IoU score regarding the expert annotation. To get that value, we want to calculate the ratio between the human coders and the M-IoU score. Once we get a ratio, and then we can further infer the estimation of M-IoU score on the expert annotation for the effort-based appraise. So by calculating the ratio from the GPT 3.5 and the GPT-4 model, we finally can get a ratio that is 1.34. By using that ratio, we know the estimation of expert annotation on the effort-based appraise is 0.57, and for the outcome-based appraise is 0.76. And then to answer the research question 2, here is our research highlights, the result highlights. Well, we fine-tuned the GPT 3.5 model, and we found that it can further improve the accuracy of highlighting the desired and undesired components in the training responses. We also examined the influence of different ratios of fine-tuning sets on the model performance. So here, we investigated like 10% of the whole data set until the 50% of the whole data set. And for each percentage, we run several random seeds to see the minimum and also the maximum performance for the model or model performance. So you can see the model generally achieve kinds of good performance when we use 65 instances as the fine-tuning data sets. And as I mentioned before, our expected model performance are kinds of estimation of the expert annotation on the EDM24 score. For the effort-based appraise is 0.57. For the outcome-based appraise is 0.76. So you can see once we use a 50% or 65 instances as the fine-tuning sets, our model can achieve comparable performance as the human experts. Our study also noted that in the data annotation process, it is really time-consuming and labor-intensive. To reduce the human labor, we further aim to leverage the data augmentation techniques with the use of 13 instances to generate more and more datasets for fine-tuning the GPT 3.5 model. And then the ultimate goal is to use these limited datasets to achieve comparable performance as the human experts. That's all for my today's presentation. Thanks for listening.